Hi, everyone. I think we should make a start, and I would like to take a couple of minutes to introduce this event. My name is Andrew Bijan, and I'm member of the committee of the Business and Industrial section of the Royal Statistical Society, and it gives me great pleasure to introduce this event today. So I'll just say briefly about the Business and Industrial section. It brings together practitioners from academia and industry who are passionate about improving the analysis and interpretation of data in making management decisions. And the section hosts regular speaker sessions and contributes to broader RSS activities to advance the use of statistical thinking, evidence-based approaches and statistical methods in business and industry, both within the UK and internationally. So before I introduce our speaker today, I would like to say thank you to Professor Giuliana Battisti for her contribution to organizing this event. And thank you for the most helpful members of staff at Royal Statistical Society who helped us to facilitate this event and provide the IT support. So thanks everyone for tuning in. What I would like to say is I was asked to say that please could we all ensure that our microphones are on mute and cameras are off during the presentation. It will be recorded, so those who don't want to kind of feature, you might want to ask questions later, and if you don't want to feature in the recording, reach out to the organizers and let us know. So, and then questions Q&A session. So perhaps we'll first listen to the talk, and then we'll leave 15 minutes at the end for discussion. But please feel free to post your questions in the chat box in the conversation panel, and we'll be able to then discuss your questions. So our speaker today is Professor Ana Beatriz Galvão. She's Professor of Economic Modeling and Forecasting at Warwick Business School, and she's coordinator of the Macroeconomic Policy and Forecasting Network at WBS. So her research on empirical macroeconomics and forecasting has been widely published in leading academic journals, such as Journal of Econometrics and the Journal of Business and Economic Statistics. And her recent research has focused on the measurement and communication of data uncertainty, asymmetries in the transmission of shocks to the macroeconomy, the impact of expert judgment in forecasting and applications of mixed frequency models. So Professor Galvão is currently associate editor of the International Journal of Forecasting and the Journal of Applied Econometrics. And her talk today is on communicating data uncertainty, experimental evidence for the UK GDP. Please, over to you, Anna.
Oh, thank you. Thank you very much for this introduction. I'm happy to talk to you, as I was saying before. So what I'm talking to you today is part of some joint research project with James Mitchell and Johnny Range. So this project was actually funded by the Office for National Statistics as part of a research program of the Economic Statistics Center for Excellence. Okay, so we're all part of this research enterprise. Okay, so the idea here is the following. I'm going to be talking about data uncertainty on economic statistics. So when people think about that, they normally think, okay, economic statistics are normally subject to measurement errors. And maybe the first thing that comes from the mind is to think about it that economic statistics such as, say, unemployment, inflation, actually, particularly if you think about unemployment, you know, it is computed by serving the UK population, which means that, of course, when you compute these statistics, you're going to have some sampling errors for it. But what we're going to talk to you today about, it's other kind of type of uncertainty that's particularly important for national account data, which is data revisions. So national account data here involves things like computing the gross domestic product or the GDP, for example. So GDP is still when the statistical office computers use many different surveys, but it's very hard to compute the sampling errors of all the surveys involved. But at the same time, it's a kind of data that's subject to data revisions. Now, these data revisions, they are manifestation of something that in the literature we call transitory uncertainty. The idea is the following. The statistical office has a trade-off. So the statistical office could wait like a year to come with an estimate of GDP after the end of the quarter, and probably that estimate would mean that they would use all possible available survey, everything will be completed, they would have done loads of checks, or they could release the data a bit faster, but this is seen as an early estimated because not all data is completed. So there is this trade-off between timeliness and reliability, and this gives rises to data revisions. Okay, I don't know if you're familiar with this idea. So I'm going to show you some numbers for the UK, so you have idea about how large are these data revisions for UK GDP. So what I want to show you is this. So this is a plot that kind of shows the average revisions over time for the UK. So they are computed on moving windows of 5 years of observations. And the way we do this is the following. We first compute the year-on-year growth rate, which is the growth rate of GDP this quarter against the previous quarter. And then we have two different estimates of GDP. The one that was just published 30 days after the end of reference quarter, which is normally a first estimate published by the ONS during this period. And then the same estimate for the same period, but published 4 years later. So 4 years after the first estimate. So you get this difference, you get the revision, and then you take the average over rolling windows. And then you have the numbers you have in front of you. So you expect the average revision to be equal to 0 over long periods. But you can see that if you look at observations up to 1988, this average revision was positive about 1. Then goes down and stays about 0.4. Then you have numbers. Let me just see if I can do something here. So what I'm saying here is that, 0 is here. Oops, cannot do a straight line. So you can see that, the average revision is normally positive for most of the period between 1993 and 2006, 2008. But then when you go when there's recession in 2008, 2009, you get actually average revisions that go negative, and then more recently they are positive. So if you look at long enough period window of 10 years, you actually find that the average revision in the UK GDP growth, it's not statistically different from 0. Now, if you look at the one measure of the size of the revision, which is the standard deviation of revision. So remember, I compute the revision the same way I told you before. You just now, over these rolling windows, I'm computing the standard deviation. You can see that the standard deviation starts here a bit about 1. Now, something to keep in mind here is that the average GDP growth over time is about 2 to 2.5. So this one is 1 percentage point above and below, which is a quite large number. And then declines over time to about 0.4 over this period here. And then with the recession, revisions are large during the recession. And then you have these standard deviations about 1.2, 1.3, and then they decline here a bit later. Okay, so this is how large the things are. So you can think, actually the number we'll be using this paper is that the average, the standard deviation for the revision is about 0.8. Okay, think about on something that has an average of 2, the GDP. So this has important policy impact. Okay, so I don't know, these slides were kind to tell you that revisions are large, okay, for UK GDP growth. The question of this slide is a bit different. So what this slide says is the following, okay, fine. So in national account data is subject to revisions. These revisions may be large. But then the question is what the statistical office do, how they communicate it, how the releases of data look like. So most of the statistical offices, and here I have 3 examples for the UK, for Canada, and for the US. They tend to publish 2 or 3 releases of GDP per quarter. And some of these releases are just going to incorporate data revisions. Some of these releases are going to incorporate new data. You can see here that for the UK, so this is not really the latest. This was from, I think, some headlines from 2019. You can see that the ONS normally gives you the growth rate for a specific quarter and uses the word estimate. Okay, so clearly say this is a GDP estimate. If you look here for the BEA that produces GDP for the US economy, they actually used the definition of real GDP growth. I mean, the ONS like to say the GDP in volume term is kind of the same thing. And then it says that increases by 2. And then if you can see in the second line here, uses the word, this is based on the third estimate. So this actually was a release of a revision of GDP. And finally, if you look at Statistics Canada, they just say the number was 0.9. So they doing here almost no comment in terms of being an estimate or anything like that. So you can see that in all these communications, they might say this is GDP estimated, but they never say which kind of uncertainty you have around or whether the data is subject to revisions. So what we did in this research was to try to understand how you could communicate uncertainty, and by doing so, how that would affect the UK public. And the reason we did that was because this kind of address some issues in the economics literature on this notion that we compute all these statistics and we normally don't tell how uncertain we are about that. If you want more motivation, think about all the issues with COVID data now and all the uncertainty around. So in that sense, the kind of issue we address here is in that line. And remember here, I've been working before on uncertainty about future values, but here what we have is uncertainty about historical values. Okay, is the fact that some things that happened in the past, so it's not uncertain about the future, but it's still uncertain about the data because of the way the data is computed. Okay, so this is the kind of thing we're interested in. The kind of approach we're going to use to try to address this issue, how you should communicate the uncertainty, take into account the statistical office normally don't communicate it. It's based on a more recent idea in which if you wanted to understand how people react to different things, you should be doing randomized control trials. So in the economics literature, there are many cases in which people evaluate the impact of policy decision with this kind of techniques, but in macroeconomics, this is very rare. More recently, there being a boom of research on people trying to figure out how the central bank communication of monetary policy could affect inflation expectations, and they're doing randomized trials too. So in that sense, we kind of contribute to that kind of ideas. So let me tell you what we do in the research. So we do a randomized control online trial. So we do an experiment online. So we do a survey online, if you want to think that way, to try to address 3 questions. The first one is to ask the UK public whether they understand that the GDP is an estimate. Okay, so I told you that the ONS kind of says they estimate, but I know many people, even my colleagues, that look at GDP and think, oh, GDP is a number. So the question is, do they think is a number? Do they think that there is any uncertainty around GDP? The second question is about if you communicate to the public the uncertain GDP. So I told you before that there is uncertainty due to data revisions. If you communicate this uncertainty with words or in a quantitative way, the question is, how the public would react or how the public would interpret and understand this communication. The third question is about how by communicating this uncertainty, this affects the trust in the producer of the data. So if you think about it, if the statistical office starts saying, look, this data is subject to revisions, these revisions are this big, it's 0.8 of standard deviation, a question that the statistical office had in mind is, oh, is that a good idea? Would people start not believing what I say anymore because there is some uncertainty in these numbers? So the way we did is we did this public survey to try to address this issue. Now we did that way. I mean, some people sometimes think they could do, I don't know, focus group to kind of address these issues. We prefer to do this because we're able to measure causal effects from the use of different communication tools on a set of outcomes. And these outcomes are related with qualitative perceptions of the accuracy of GDP estimates, are related with quantitative perceptions, and is looking at the public understanding of the causes of data revisions. I think these things are going to be clear when I kind of show you the kind of questions we ask. But the idea you should keep in mind is that you really wanted to see if the different communication tools have an important impact on the perception of the public, and we do this via this randomized experiment. Now, we're going to be using 6 different communication tools. Okay, the first communication tool is basically the way that normally the ONS releases the data that says the GDP is now a number and this is an estimate. This is what we're going to do. Then we're going to add some qualifiers. We're going to consider the case in which we use the word about to give, to, I don't know, emphasize a bit the notion of estimate. And then we're going to use a case in which actually we explain why is a estimate. So we're going to say is a estimate subject to revisions as update information becomes available, which is this notion that over time, you know, the ONS has better survey responses and is able to come with a better estimate of GDP. And we're also going to consider some quantitative communication of uncertainty. We're going to use both words and figures to try to communicate this uncertainty. And we're going to use 3 different plots. We're going to use a predictive interval, a density strip, and a fun chart. I'm going to show you this in a second. And of course, because this is a randomized experiment, so the allocation of responded into groups is completely random. So the software does that online. So, which means that the the communication tool we've got, it should not be related with any kind of individual characteristic you have. Now, the results I'm going to show you today are based on a survey that we did in November 2018. And we actually used 2018 quarter 3 GDP values available at that point in time. I'm going to show you also some indication of some results of a more recent survey that we did this August with the most recent GDP numbers. I already told you what we did. Maybe I should tell you exactly which kind of uncertainty we try to communicate. I already showed you the numbers of data revisions before. So what we're going to assume that the uncertainty can be well characterized by a Gaussian density, which is something that some central banks have been done before. Actually, the Bank of England communicates the uncertainty GDP using Gaussian densities, and the Central Bank of Sweden does something similar to that via fun charts. And we're going to do the uncertainty on these year-on-year growth rates that I showed you before. And we're going to use a standard error of 0.8% or 0.8 percentage points if you prefer, okay, which is the average over the last 10 years. Now, the GDP year-on-year growth rate in November, actually in 2018 quarter 3 was 1.5%. Oh, good times. And that means that a 90% interval is between 0.2 and 2.8. It looks pretty big. In a second wave, we actually did the same size interval for the current decline of 21%. But the idea here is that the data uncertainty shouldn't be strictly related to the initial values. Okay, so this is the communication tools we use. So the first 3 here are the ones just based in words. So the first one is the standard one. The second just has the word about it. And the third one has this notion that is subject to revisions. And then the other 3 are quantitative ones. So you has the same phrases as before. It's just one of them has this interval and has some words explain what the interval is. It says, look, the interval is between 0.8 and 2.2, and that means that there is a 6 in 10 chance of the GDP being this interval. So this is a 6% interval, and then of course 4 and 10 outside the interval. We do the same thing with density strips. So this one is a bit more complicated. They have 30% in the middle, and then 60% here, and then 90% on the light coverage, and the text kind of explain what that is. And finally, we did this. So this is a kind of bell shape way of communicating this. So you can see the 1.5, you probably cannot see because this is too small, but the respondents could be able to see that in their screens. So this is 1.5%, which is the GDP estimate. And then here you have the shadow areas of the 30% probability, 15% in these corners and 50% in the outer corners. Okay, so this is the 6 different ways we do it. And we try to use words to explain what these plots mean. This is basically how we're going to measure the impact of these 6 different communication tools on a set of outcomes. So we're going to be using probit regressions. Maybe I shouldn't spend too much time explaining this. So let me go to the questions or to the outcomes we're trying to measure. So the first set of outcomes is a set of questions that measure the qualitative perceptions of accuracy. So the way the survey was done is that there were initial 10 questions asking some individual characteristics, and actually asking some questions on the knowledge of the respondents about the ONS, if they knew what the ONS is, what if they knew what GDP was. So the way we did that, we asked the definition of GDP, and then if they got wrong, we would tell them what GDP is. And then after that, they would have this randomized screen that they would show each one of the 6 communication tools I showed you before. And this is all shown randomly, and each group will have the same number of respondents, which is about 500 in each group for this wave. And so this is then would come some questions. So one of the questions is, how accurate do you think is the first estimate? We aggregate answers that said is very accurate and very accurate. Questions about how surprised you'll be if the GDP then is changed to 2%. We thought at that point in time that the difference between 1.5 and 2 is pretty big. So we wanted to see if they would be surprised with that or not. And then whether they will be surprised if GDP were regularly revised. So let me show you a table now. Now, so each one of, so these ones are 3 different outcomes, if you want, which is basically answers from 3 different questions. What you see here in the bottom is actually the average that you get from group 1, which is the control group, or is the group that has any kind of, just had a standard. So you can see that 80% normally says that the first estimate is very accurate or very accurate. And then you can see that these numbers here are basically the difference for people that got different treatments. So you have here group 2, 3, 4, 5, and 6. So group 2 and 3 are just qualitative measures, and group 4, 5, and 6 are quantitative measures. So basically you can see here that this number here being negative means that you're 4 percentage points less likely to answer this question as saying the GDP is very accurate. So what this thing means is that you lose a bit the notion of the accuracy of GDP if you see, for example, the interval, or if you see the word about. Okay, and these numbers here are T statistics, so they're in bold, means that the statistic is significant. About the second question, about being surprised of having a revision, you basically see nothing here that's significant. So in this sense, you can see that the people that got the interval, for example, are more likely to not be surprised, but is not significant here. And the third column here is about if you're very surprised that GDP is revised, and you can see that all these numbers here are negative, and many of them are large. So, for example, this is 6.6% percentage points less likely to answer the question that you'll be surprised that GDP is revised, which means that people want to see this treatment understand a bit better that GDP is subject to revision. Okay, so here is the qualitative. I have a more clear answers when you go to the quantitative part. So the next set of questions ask very specific questions about, what do you think is the chance of GDP growth exactly 1.5%? So here you wanted to see whether people attribute some uncertainty around GDP or not. So we're just going to see the proportion of people that actually were pretty certain about GDP numbers. We asked questions about whether they couldn't understand the probabilities between 1.2 and 1.8. Of course, for people that got the quantitative numbers, this should be a straightforward mathematical question if they, of course, if they can understand what's going on. We also asked them to give you some limits, some intervals for GDP number. And finally, we asked them to tell us how informative was the communication of GDP. And this is basically what this table full of numbers does. So as before, here in the bottom, you have basically the proportion of people answered this option on the control group, or in people that don't see any uncertainty, any communication of uncertainty, or only the standard one. And you can see that 45% are quite certain about GDP, which is interesting because that thing that 55% of the people, even if you don't say anything, are not sure about GDP. So they might have a notion here that GDP is something subject to uncertainty. And then for people that seeing some of the quantitative measures of communication of uncertainty, such as the interval, the nasty strip, and the bell curve, these ones are really are more likely to say, look, I really cannot see this being a certain number. So they can evaluate better the quantification of uncertainty around GDP. They're also better in getting the probability of GDP between 1.2 and 1.6 right. So the right answer was actually 30%. And the people that saw the quantitative communication, particularly the interval in the bell curve, I think the density strip was a bit too complicated, were able to answer this correctly more frequently. And remember, this should be causal effects. So that should be the impact of the communication of uncertainty. And finally, everyone that got some comments on the fact that data revisions are due to the information set or got any quantitative measure of uncertainty says that they are less likely to say that the information content of this statement was very small. Okay, so this is kind of shows that by showing these density strips or intervals, we were giving more information for the public. And the final kind of set of questions were questions about if the way we communicate uncertainty changes the views about why the revisions are out there. So we asked the public whether they think data revisions come from vested interests, either from the ONS or from the government, if data revisions are due to mistakes, or if data revisions are due for additional information. So you can see here in the bottom that at that point in time, 31% thought it was due to vested interest, 10% to mistakes, and 50% due to additional information in the control group. And the impact of these different communication tools is basically, statistically equal to 0, except for the addition for the question on the part on additional information, in which people that seen the bell curve, for example, think that are more likely to think that data revisions come from additional information. So we see this as a way of saying that even if you're communicating additional information with the uncertainty of GDP, people look at these bell curves and these intervals. They understand better the quantification of uncertainty, but they don't mistrust the statistical office because of this. Okay. So that's basically summarizes. So we think, based on these results, that the majority of the public understand that there is some uncertainty in GDP numbers. I told you at least half of them thought it was not exact number. But we think that when we communicate uncertainty, they improve a bit of the understanding. So in particular, it improves this probabilistic measurement of the uncertainty on GDP. And at the same time, clearly doesn't seem to decrease the trust one has in the data. Okay, and it looks, if you look at our results, there are many cases in which the intervals and the bell curves do show some contribution. So which means we can say that they do improve the communication of uncertainty. Okay, maybe I don't talk this too much. So we try to, one of the questions we ask before we show the communication tools was actually to ask whether they trust the ONS, and we could link that to some of the answers. There clearly are no a link between trust and thinking that the GDP estimate is an accurate one. Okay, so this is the last thing I want to talk about. So we did a second wave of this survey during August. We did the second wave for two major reasons. The first one is that, as I show you the results of the first wave, this was based on a GDP estimate of 1.5%. So the economy was growing. So what we economists call was during an expansion period. And we wanted to see what happened if you do similar thing during a recession period. Of course, we're in a recession now in the UK. And other reason we did is because during this last year in which we'll be talking about the results of this research, the ONS is kind of keen thinking about different ways of communicating the uncertainty in the data. So if you look at the last press release of the ONS, you see comments like this one you see in front of you. So they said, look, there are more, the estimates are subject to more uncertainty than usual because of the challenge the ONS face in collecting data under the public health restrictions. So they mainly related to the impact of the lockdown data collection. So we try one of these communication of uncertainty here. So it's still with words, uses the same kind of phrases we had before, it just has this additional information. And another one is that the ONS has done some work. Actually, I contributed that work to in try to measure the uncertainty of on GDP for the last 2 years. So you see, I have data here from 2018 quarter to 3 until 2020 quarter 2, and this is based on some measurement of data revision similar to the measurements I showed you before in the beginning of this talk. I mean, you probably can almost not see the dotted lines here because of scale, but these are basically a 68% interval, or there is a 2 in 3 chance that the final GDP estimator will be between these intervals. So you can see that, of course, is positive, so 0 is here. For most of for 2018, 2019, and of course it gets negative in the current year. So we show that as well. And our preliminary results kind of suggest the following, that in particular this kind of statement here, G7, um, it does seems to have an impact on the perception that the initial GDP is accurate, which I guess is what that statement means. Something that's interesting in this new wave is that it looks like both the interval and the bell curve are still the kind of communication tools that help the respondent to get the quantitative questions right. So they seem to be a pretty interesting way to do so. And at this time, we found that the communication tools have no impact on the perceptions of the causes of data revisions. But we still have to do more work on this data. That's why I'm not showing all details today. But it looks like that it confirms most of the main takeaways we got before. Okay, so I guess I should stop talking now and then you can ask me questions. But I'm just trying to conclude here. So we did these randomized experiments to try to figure out if and how data and certain information matters, and if it matters the way it's communicated. We're doing this for GDP, which is a very economist kind of thing to do. But of course, this is based on there's much more evidence and kind of issues addressed this way in interdisciplinary literature, including, communication of uncertainty on, for example, on some estimates related with health, for example. Um, and so we and links between communication of uncertainty and trust. So this is something that is there in psychological literature. So we think we link into this kind of research. And another thing we want to push here is this use of randomized control experiments, which I think is an interesting way to try for us. So if you want to try different things, and here we want to try different methods of communicating data uncertainty, then we think this is a methodology that can be very useful and seems to be very useful in this kind of exercise.
Perfect. Thank you very much. This is very interesting, Anna. We have a couple of questions already, but I'll just ask you a very quick one. How did you identify control groups?
Is randomized.
Randomized.
So the control group is basically the group of people that get just GDP as I estimate and is 1.5%. So we define that as the control group.
Okay, thank you. So the other question is from Paul Smith, who is asking the division of a set of graded responses into two categories, 0 and 1, is likely to obscure some of the pattern about how people's views are modified by uncertainty information. Have you tried an ordinal analysis using the different levels of this variance?
Oh, I have many discussion with my co-author James Mitchell about that. If you're going to do the choice or if you're going to order probe it. Thank you for that question. When it previously still debated on how best to measure this impact. So yeah, our initial work actually using order probit was that the order probit and the probit were giving very similar effects. But that's an issue we're still thinking about for the new version of this project, which kind of method we're going to use to measure the impact on the outcomes.
Thank you. Trevor is asking, is there a change in perception between Q3 2018 to Q4 2019 when the next estimate was in the predicted range, with 2020 when the predictions were outside of the predicted range?
Oh, I'm not sure if I understood that one.
Yeah, you might want to have a look in the conversation. So it's the one.
Let me see. Let me see if now I can see things, because before I was completely blind.
It's the one at the bottom.
So something we must say. So because we imagine here data uncertainty. So we measure data uncertainty, right? So we actually don't know the outcome of GDP. We're going to take us 4 years to figure out how large is going to be the revised value of GDP. Now, something that I think is related with this question is the following. It's true that the economy was growing at 1.5% in 2008 Q3, and now, of course, the economy is in a recession. So when we did waves, that's the kind of issue we try to disentangle, whether the state of the economy would change the way people understand data uncertainty. Our views from the kind of work we did in the past is that data uncertainty might be a bit higher during recessions, but at this point it's very hard for us to figure that out. So we try to keep the size of data uncertainty kind of a constant between both waves. But let me know if it's not clear. Just ask me directly, I think.
Okay, and Juliana wanted to ask a question. Juliana, would you like to unmute yourself?
Yes, hi. I was trying to type into the chat, but doesn't work, my chat. So thank you, Anna. It's very interesting. It's really, I really enjoyed your presentation. My question was about the type of respondents, whether you find that the perception changes across typology of individuals, and which was the criteria, because, sorry, this linked to the second part, because I presume the perception of uncertainty might have a different impact on behavior, on decisions of the actors.
So this is something actually we're going to try to do now on the. So in the second wave, we add some additional questions that include a decision on so something we always wanted to do is whether the perception affects decisions. As you saw, there was no questions here that somebody has to make a decision. In the second wave, you had a question about whether people were thought it was time to do a purchase of a big ticket purchase, a car or a large piece of furniture. We haven't looked at that data yet to see if this has any impact. Something we know based on the previous wave is how these outcomes are related with, for example, with education, or if they know what GDP is, if they pay attention to news. In our sample, actually, since it's representative out of the UK population, I think half of the sample didn't really know what GDP is. But of course, we still can use the sample to measure the impact of these treatments, because even if within a group there's lots of people that know GDP is, you can still use that to measure the impact of these communication tools.
Can I ask you, based on your experience, because I know you teach also students that should know what GDP is. I think there is an issue about statistics, and a lot of people don't know how to interpret them. But there is another issue about those that know what the statistics are about. Do you think they still perceive? Are they fully aware of what the margin of error or this uncertainty is about?
So we actually had a companion survey that we actually asked the economists or the experts, so the people that know what GDP is, and even people that know, we actually asked them a bit of a measure of uncertainty. So for them, we actually didn't communicate the uncertainty because we couldn't randomize because the sample was too small. But what we did was to ask them a measure, and there's a gigantic amount of disagreement, and so they yeah, so there's a gigantic amount of disagreement. So our view on that is that, so the fact that there is no official measure of data uncertainty. So if you look at the ONS, you find some measure of data revisions, but there's no official version or no official communication, means that even for the experts, that people really know where GDP is, they if they're not doing research in this area, they have no idea how large it can be.
I would like to say thank you very much, Anna, and thank you all the participants.
Yeah, thank you all, and let me know if you have any additional questions that you want to ask me when we're not being recorded or anything like that. It's fine. You can email me.
Perfect. Well, thank you so much, everyone. Have a great week, and do get in touch with Anna or organizers if you have any follow-up questions or discussion. Thank you.
Thank you for everyone attending. Thank you. I can see I know some of these people, so thank you for coming.